So guys, in this chapter, we're talking about the concepts behind integrals. It's not going to be so much like what we did the first time we did integrals, where you actually do the integrals, like use substitution and stuff like that. It's going to be more like the idea of what integrals represent, and a lot of AP style questions you'll see will come out of it. So we're going to be talking about area under the curve and how mathematicians would estimate area under the curve before they actually got to the place where integrals come into play, which is where you actually get an exact area of the curve. Riemann sums is a way to kind of estimate that area, and that's what we're going to be looking at for the next few days. Let's go ahead and begin this process. So whenever I first introduced you guys to integrals, I gave you a problem that looked like this. And this is a way you can estimate area under a curve. Basically, you can just draw little rectangles. And what we talked about at that time was we talked about how the more rectangles you have, the more precise the measurement is. And when you let the number of rectangles approach infinity, which would require you to make the rectangles infinitely small, you get the exact area, which is where the integral comes from. So if you add up all these rectangles, you're going to get something pretty close to the actual area under the curve, and that's what this little equation down here on the bottom represents. We're going from 0 to 2, and that would be the area on that interval approximately. So let's go ahead and proceed here. All right. There are 4 ways to do this, and we have to know all 4. There's the left-handed sum. That's where each of your rectangles touches the curve at its left corner. A right-handed sum is where each of your rectangles touches the curve at its right corner. A midpoint sum is where the rectangles touch the curve at the midpoint of their base, up there at the top. Now, which one of these would give you the best estimate? Midpoint would, right? Because right-handed sum here has a lot of overage, left hand has a lot of underage, but midpoint has a little of both, and they're almost symmetrical, so they kind of cancel each other out and end up with an area probably pretty close. Right? So there is a 4th one that we're going to talk about as well, and it's called the trapezoid sum. That one's also pretty precise. It's better than left or right because instead of drawing rectangles, they draw trapezoids where they connect the points with a straight line. And the straight line follows the curve's direction at least. It's not the curve, so it's a little bit off, like here. Depending on how curved the line is, you get a better or worse estimate. But trapezoid sums are also a good way to get pretty close answers for area under the curve. Okay, so we're going to be looking at right and left-handed sums today, and then on Thursday, after our little district test tomorrow, on Thursday we'll talk about midpoint and trapezoid sums, and then on Friday we'll just look at more problems, different ways that those problems could be asked. And that'll be it for the week. Now, let's go ahead and take a look at this. When it comes to doing a right-handed sum or a left-handed sum, sometimes you could say this is an overestimate or an underestimate. Now, you could tell by the pictures what they are. Like you can look right here and know that this would be a overestimate, right? Because the rectangles are going above the line. However, it's not always so easy to look at, and you'll see what I mean when we get to some examples later. It gets really confusing when your graph goes below the x-axis. Everything gets reversed, and your brain's like, doesn't quite know what to do with that. So there's really 2 criteria that determine whether it's an overestimate or an underestimate. Now, why do we care about that? Because there are actual AP FRQ questions we're going to look at where you're not even going to look at a graph. You're just going to be looking at a table of data. And you have to know, is this an overestimate or underestimate? And so it depends on 2 things. It depends on whether your curve is increasing or decreasing on that interval. And it also depends on whether you're doing a left-handed sum or a right-handed sum. So if you have a curve that's increasing and you're doing a left-handed sum where the corners of your rectangles on the left side are touching the curve, it will be a lower estimate. If you do a right-handed sum with an increasing function, it'll be an overestimate. But everything gets reversed if you let the slope go downwards. So if I have a downward sloping function, then now a left-handed sum is an over, and a right-handed sum is an under. So it really depends on two criteria, the slope of your function and also what kind of sum you're doing, right or left-handed. So that's how your explanations would have to go too on the FRQ. You couldn't say something, for instance, well, because look at it, the rectangles are above the curve. Even though that makes sense to you, the explanation would have to be, oh, this is an overestimate because I have a negative slope and I'm doing a left-handed sum. Okay? So that'll help you with that. Just keep that in mind. Proceeding onwards. Sometimes they call underestimates lower sums. Sometimes they call overestimates upper sums. I'm just going to say underestimate and overestimate, but just be aware of the vocabulary there. And this process of adding little miniature pieces of geometric shapes under a curve and adding them all together is called a Riemann sum, named after the guy who kind of founded the whole principle. All right. Now, I spent 2 hours on this lesson this weekend, refining it. Last year I had a really hard time. And now I taught it this morning, and I had just as hard a time. So, and here's why. You're not going to do what I tell you to do. I'm going to tell you to do something, and you're not going to do it, probably. You're going to do what feels right. And I don't know how to get people around that, but that's the issue. Okay. So here's what we're going to do. I don't know, but I'm going to come at you guys a little bit different than first period to see if I can kind of avoid the error. But they fell into the same pit last time as my other classes. So here we go. We're going to draw some Riemann rectangles on this curve to estimate the area. I'm going to do it once with a right-handed sum, and I'm going to do it again with a left-handed sum. And you're going to get two different answers. One is going to end up being an overestimate, one's going to end up being an underestimate, and we're going to have to explain our reasoning. Okay, so that's it. That's what we're going to do. Okay, so it's a two-step process. Maybe I should say it's a three-step process. Ready? So the first thing you got to do is you got to ask yourself, am I being asked to do a right-handed sum or a left-handed sum? Okay, I'm being asked to do a right-handed sum. So what that means is I'm going to start on the right side. You guys good? So that's step one. What kind of sum are you doing? You're going to start on the right side. All right. Sounds easy, right? All right. No, left. What? No, I'm just joking. Okay, so we're starting on the right side.
This is how your class got confused yesterday.
No, I'm just making fun of it. Maybe it is. All right. So now, step one. Am I starting on the right or the left hand? And the answer is step one is easy, right? Okay, step two. We're going to draw a bunch of horizontal lines, and these are the tops of my rectangles. We're starting on what side? The right side. So I'm starting over here on the right side, right? So here we go. Start here, and you're going to draw a horizontal line till you get to where the next dot is. Just straight over. Repeat. Straight over till you get to where the next dot would be. Repeat. Straight over. The last one, we're going to put an X on it. We're not going to go straight over there because my curve stops there. If I went over more, I'd be putting a rectangle here, and there's no rectangle there, right? There's no line there. So you're not going to use the last dot. Okay, so let's review our steps. Ready? Step one. I know. Guess what? Start on the right side, and then step two is, starting on the right side, we draw little horizontal lines, right? Now this last step is the one that gets people. Ready? You're going to draw lines straight to your x-axis from your horizontal lines. So from the horizontal lines, you're going to draw vertical lines straight to the x-axis. Ready? So straight to the x-axis, right? Straight to the x-axis, right? You guys good? How about here? That one's confusing.
To the
That would not be going to my x-axis. That would be going down. So you do nothing. It's on the x-axis. So what that means is this rectangle here has a height of 4. This one has a height of 3. What's this one's height? It has a 0 height. That happens. You guys good? All right, so there's our 3 steps. Sounds easy, right? All right, we'll see how easy it is. So step 1, start on the right side. Step 2, horizontal line starting from the right side. And then we're going to draw vertical lines that go to the what? X-axis. I know it's tempting. Don't do that. That's not going to the x-axis. That's going away from the x-axis. Okay, so anyway, there it is. So now what this symbol here represents, you guys, is this represents the actual area underneath of that blue line. But we're going to estimate the area with our rectangles. So what is the area of this rectangle? Well, base times height, right? What's my base? Is 1. And what's my height? 3. So 1 times 3 is? What's this area going to be? And so this area is approximately 3 plus 4, which is 7. Okay? All right. Now, I don't want you guys to look at the picture. I want you to use the graph on the other side, the chart, about increasing, decreasing, etc. Is my function increasing or decreasing? It's increasing. And am I doing a right-hand or a left-hand sum? Okay, look at your chart. When you have an increasing function with a right-handed rectangle, what would that be? It's an overestimate. So we're going to say overestimate because 2 reasons. F of x is increasing, and it's a right-handed sum. That's how you would have to explain it on an FRQ, because it's increasing and it's a right-handed sum. Okay, so I'm going to call people to walk me through this other one. Okay? So, you guys ready? All right. I'm going to ask Brandon. Brandon, take a moment to read the directions up there at the top. Where do I start? You start on the left this time. That's step 1. All right. Step 2. Juliana, what do we do for step 2? Draw little horizontal lines starting on the left. Okay. Where's Nathan? Nathan, can you come draw my little horizontal lines starting from the left? All right, come on up. Starting from the left, I want you to draw me little horizontal lines. Maybe I'm going to do better with you guys. All I know is that first period, they had a hard time with it. And every year's had a harder time with it. Okay, just use your finger.
Wait.
Starting on the left. And you're just going to draw little horizontal lines starting on the left side.
Right.
Mr. Bailey.
Mr. Bailey, I swear to God, this is all it is. I'm going to be upset because you made it seem like it's so hard.
I'm not sure. Is it not the same?
That would be starting on the right side.
On the right, so we'll go like this.
Well, now you're off your line.
So I don't get it.
So what dot is on the left? The far left. There you go. So that's where we start.
We're starting here.
Uh-huh. You go left. There you go. Repeat.
Okay.
Repeat. Go all the way over. Yeah. There you go. Good. All right. Thank you, Nathan. Nice. Okay. Now, the next person has a real challenge. All right. Any questions so far? You got it. You got. By the way, we don't do the last dot, right? Did you go off the dot? Okay. Alyssa, what's the next step?
We draw lines to the x-axis.
You draw what kind of lines?
Wait, no, I'm sorry. Vertical lines.
Vertical lines to the x-axis from our little horizontals, right? So now I'm gonna ask Angelisa to come on up here and draw me my horizontal lines. You guys should try it too, real quick. Yeah.
Really, I'm about to work right now.
You might.
And you can't even be mad at this point.
I'll be mad.
No, you won't.
I'll judge.
Go ahead, judge me. But will I care?
Overplaying it? You would think so. I came in all confident. It was like, draw your lines. And when I got to look at people's papers, I saw these weird things. I was like, oh no. Not
So we
again.
don't do one up down.
Keep going.
Keep going. What the hell?
Nice. You're not done yet.
Wait. What the hell?
That's not a rectangle. Well, you just recorded the F word for all the world to hear. Thank you for that answer. Okay.
You're the one that made me spell it.
You're confused?
No, I'm confused on how people are confused.
Me too.
I'm confused.
All right. So, but I'm teaching you different. So don't be too cocky. I'm showing you guys differently. All right. So you start. She was right, but I just want to see you guys do it again. So from your little horizontal hats, right? I call it a hat for this on top, right? So from your little horizontal hat, you draw a vertical line straight down to the x-axis, right? But when you're down here, the x-axis is which way? Okay.
So when it's left, the last one, oh.
Yeah, you don't need to finish every sentence with the F word.
No, I have a
Yeah, most people say excuse me.
Well, sorry. I was in the
Most
middle of
people
a
go,
sentence.
oh. You know.
Yeah. Sorry.
All right. Yeah.
So when it's from the right, the last freaking point is on the left, and it's on the left, the last one.
Yeah, so you always leave the last one off, right? So when you start on the right side, you leave off the last endpoint, and when you start on the left, you leave off the last endpoint. You don't include. That's how our graph looks. It looks really weird, doesn't it? You know, some people get it.
I need to know.
Anyway, now we need to do our. Now let's do our. Ooh, squeak. Let's do our. My voice cracked. Okay, so my area is approximately equal to the area of these rectangles. But we got to be careful. So Ashley, what's this area here? 3. Here's one of those flat rectangles. It's not a rectangle at all, right? All right, now tricky question, Ashley. What's this area?
Are we talking about the area?
I,
Okay, so would it be, I don't know, like 2.5 or something?
no.
What about like the whole rectangle?
What's base times height here?
Oh, okay, so the whole thing.
Yeah.
So it's 5.
That's right, but it's
Well,
under the curve,
that's what I just-
so it's negative
Oh, okay.
5. Negative 5. Remember, this is something we talked about months ago. Remember that? Months ago. Area under the curve is negative, right? Okay, so here we go. We have 3 minus 5 is negative 2. So here's the deal. Well, actually, let's finish. Good question. Use your chart, and I want you guys to determine if this is an overestimate or an underestimate, and then I'll explain why that actually makes sense, even though it doesn't look like it makes sense. So go ahead and look at your chart and decide if this is an overestimate or an underestimate.
It's not 5, it's minus negative. Oh wait, no, never mind.
It's an underestimate.
If you guys do better, no, I'm posting this one. But otherwise, I'll post this. No, that'd be confusing. Is Sam here? I don't see Sam
Send me
here.
the link on my
All right, Serena. Over or under? Underestimate. I'll take that, but I need an explanation. So I'm just going to put a dot there, and I'm going to ask Aaron, what's my explanation going to be?
Because f of x is decreasing.
It is increasing. And we are doing good. Look at your table, guys. We have an increasing function with a left-handed sum. That's an underestimate. Now, Let me tell you why this makes sense. Now, guys, look up here. Look up here. You with me? This makes total sense. That rectangle is under the curve, so it's an underestimate, right? Here's where it stops making sense. Look down here. The rectangle goes beyond the curve, but it's a negative area, which means it's more negative, which means it's still an underestimate. Does that make sense? So when it's upside down, it makes your brain flip out. It doesn't make sense anymore, but it does. It really does. Okay, so there's that. All right, so I walked you guys through it. Let's see how you guys do. It's your guys' turn to shine. So now I'm going to ask Dario, what did you get for tell me what each of these little areas are down here. This one? This little rectangle here, Dario, that's -1, right? How about this one? Negative what? Okay, so the base is, and the height is negative, of course, is -4. How about the last one here? Okay. Max, what's the estimate for this area? -10. I'm going to ask, Jennifer's not here today, so let me ask Manny, overestimate or underestimate? It is an underestimate. I'll put UE. Why is it an underestimate? Nakaya, why is it an underestimate? Huh? That's part of it. We have a, well, actually, this is a right-handed sum. So, yeah, I guess you could say it, but we're a right-handed sum. And also because why, Manny?
Isn't it because, like, how it comes in contact with the, like, plot thing? Like, you can't you tell, like, visually?
I wouldn't.
No.
I wouldn't.
I can't.
Brandon?
Like, decreasing and it's a negative slope?
There you go. Well, you would say because it's decreasing and it's a right-handed sum. You have to have those two things in there. It's a decreasing with a right-handed sum. Now look at it. Those rectangles look like they give you more area than the area under the curve, right? But they give you more negative area. So it's an underestimate. All right. David, what did you get for this little area over here? The final answer? Good. Good. The 4 is canceled, so yes, you do end up with an estimate of an area of -1. And Christian, is this a overestimate or underestimate? I believe it's over. Now, how do we know that? Is my function increasing or decreasing?
It's decreasing.
And this is a left sum. So look at your chart. Decreasing with a left sum is decreasing and left. All right. So that's a Riemann sum for you. We're going to look at this problem from another perspective now. Find example 2. Not yet. Slow down, slow down. Okay, here we go. So I'm going to do this in a very similar fashion, okay? But I'm going to show you another way to do it, which you'll be very thankful for when we get there. But for now, I'm still going to build your understanding based on to get to that point. So for now, for each problem, use a left-handed Riemann sum, so that's kind of worth underlining, to approximate the integral based off the values in the table. So we're only going to be approximating this integral. So here's what I'm going to do is I'm going to turn the table into a graph, and I'm just going to do the same thing I just did. Okay? So here we go. Let's plot all these points. 0, 4. That's my first point. 3, 2. There's my second point. 4, 3. And then 8, 4. 5, 6, 7, 8, 4. 9, 5. Okay, now I'm not going to connect these dots with a line because I have no idea how these dots are connected. Okay, now I will do it, but I don't want you guys to do it. I could do this, right? That works. That looks pretty. But don't you guys agree I could also do this? There's no reason I couldn't do that, right? So I don't know what the line looks like, so I'm not going to draw it. But that's okay. We don't need it because we're drawing rectangles, right? Okay, so here we go. I'm going to walk you guys through it. Sam, what side do I start on, left or right? Samantha?
Left.
Good. Ryan's not here. Let's talk to, I don't think Chris is here either. Christopher Ignacio? Brody, can you draw me my horizontal lines only, please? Remember, we're starting on the left.
Left-handed, so this one will go all the way to here, and then this one all the way to here.
Good.
All the way over here.
Good.
Leave that one alone.
Excellent. Thank you, sir. And you don't have to do this, but I like to exit out. But all right, next, I'm going to ask Dylan to come up here and do the next step. Next step is to turn them into rectangles by drawing the vertical lines that go to the x-axis. So Dylan's going to do that. Now this part's a little bit hard, just so you guys know, because if you're drawing your own graph, like even though my dot has an x value of like 4, by the time I get down to the bottom, it like skips over to the 3. So you got to be careful to make sure it goes right to the right spot on the x-axis. All right, now we get to figure out our areas. So why don't you guys go ahead and compute your areas for these 3 rectangles, please? Compute your areas for these 3 rectangles. Did I say 3? 4 rectangles, sorry. You just start on the left.
Oh, no. I didn't finish the last one.
All right. You guys got your areas calculated? All right. How about now? We got our areas?
Yeah.
So I'm going to ask Zach. Zach, can you tell me the areas of each of these little rectangles here, please? Uh-huh. This is 4? I think that is 2. How about your next one, Zach? 24. So let's see. This is 1, 2, 3, 4, right? With a height of 12, or sorry, 3. So that's going to be 12 as well. How about, want to take your shot one more time in the last one?
Yeah, that would be 10 or 8.
So what's my base here, Zach?
2.
That base is 1. The width of my rectangle is 1. What's the height of the rectangle? 4 spaces high. Are you counting the lines?
Yeah.
That's what it is. You don't count the lines, you count the spaces. So the rectangle is 4 spaces high and 1 space wide. So 4 by 1 is 4. So your total area is going to come out to be what, Miss Maya Bailey?
The total area, that's when I multiply all the, no, I add them together.
Yeah.
130.
Okay, good. Now, it would be wrong for me to ask the following question. Is this an overestimate or an underestimate? Here's why. Because no matter how you want to connect these dots, is this function always increasing? Is it always decreasing? Isn't that kind of what determines that answer? So since it's not just increasing or not just decreasing, sometimes it's an over, Sometimes it's an under, and you can't really decide, did this turn out to be over or under altogether? So because the slope's changing, I can't really ask that question. All right, but there it is. Let's go ahead and have you guys try one. After this, I'm going to show you guys a shortcut. Some of you may already see it, but be careful. Now, this is important. You guys ready to get your attention? This is not example 3. This is student practice 2. I did not print the problem for you. So don't work on example 3 right now.
Do that. Oh, I love doing it. I got my 50 a different way.
Oh, you mean the wrong way?
No, the right way.
All right.
Right.
50. And Jade, why should I cross this question off? Why would I not ask you if it's an upper sum or a lower sum? What changes? The slope. Very good. All right. Now, I'm going to make you guys happy here. And you're going to be like, why didn't you teach me that? And it's because shortcuts are only useful whenever they make sense. Otherwise, you abuse them and don't use them at the right time. So, let's go ahead. I want to show you guys a shortcut here. Ready? Now, what is the height of this rectangle here over here? What's the height of this rectangle here? How about this one? How about this one? Do you guys see those numbers 4, 6, 5, 3, 2? There's all your heights. There's all your heights, correct? I didn't use this one, right? So I don't use that one. You good? So you don't use the last number, but all these numbers here are your heights. Right? Now, the bases of your rectangle are a little bit different. This base is 1. What's this base? 6, 1, 1, 1, right? Well, where the heck is that on the table? It's not as obvious. It's the differences between the x values. Like, for instance, how far away is 10 from 9? So we show it right here. 1. How far away is 9 from 3? 6. There it is. How far away is 3 from 2? 1. 2 from 1. And 1 from 0. And it's base times height, base times height, base times height, base times height, base times height. 2, 3, 5, 36, 4. You got your answer. So, that's it. That's your shortcut. You don't need a picture. Okay? So let me walk you guys through it now with an actual example problem. Makes the problem go by much faster. And this is the real skill that you guys need for your AP test, is this. Because on the AP test, I would not advise drawing the picture out. Now, the only downside of this is that if you don't see the picture, it's a little bit harder to know if it's an overestimate or underestimate, but not if you know how to explain it properly. Because then you can tell, oh, the function's increasing and this is a right-hand sum, so you can figure it out. All right, here we go. Let's go ahead and take a look at example 3. Now, you have to pay attention to something here. What do I have to pay attention to? So let's underline that. I'm going to circle all the numbers on the right, but I won't include the last one because these represent my heights. Now, if I told you guys this was a left-handed sum, you would circle all of these ones and cross that one off. Does that make sense? Okay. So, oops, too far. Okay. Now, let's find my bases. My bases are 0 to 2 is, 2 to 5 is, 1. These are my bases. And all we do is base times height, base times height, base times height. So 1 times 1 is 1. 4 times 2 is 3 times 1 is And then 2 times 0 is 12. Done. Much easier.
Mr. Ray, what did you say about crossing out a number or something?
Yeah, so if it's a right-handed sum, you're going to use all the numbers starting on the right, but you don't use the last one. Just like when we're doing our graph, we don't include that last dot, right? Same thing when you're doing a table.
So wait, the 1, 2, 3.
That's the distance between the x's. So like from 0 to 2 is 2. From 2 to 5 is 3, etc.
So if it was left-handed, we would cross the last one?
All right, let's do another one. Ready?
Let's go.
You just made my life. No, I mean like in general. You're gonna get the graph.
All right, we're gonna do the student practice here. It's the same table, but now we're doing a left-handed sum. So let's do this as a guided practice. Isaac, which one is not a height?
Oh.
It's a left-handed sum.
No,
No, that is a height. Since this is a left-handed sum, we're going to use all these numbers on the left, and we drop the one on the right. Okay?
I got my left and right.
Gotcha. Jacob, what are my bases? Like, those aren't my bases, though. 1, good. 4, 3, 2, good. That's what I wanted. I didn't know how else to say it, but yeah. Roxanne, what's my areas going to be?
2, 4, 0, -2.
Good. Because you just go straight down, right? Multiplication. And that's going to be 4. Good? All right, I want to throw one more at you guys. Let you guys do it all on your own from beginning to end. Let me out of here. Okay. Okay, I want you guys to do a left-handed Riemann sum. Go. Do a left-handed Riemann sum to estimate the integral. But I'll tell you what I did differently. Left-handed. We're using those and not that.
What did you do differently? I don't understand. I feel like even if you taught it the other way, I would have understood it. How did you teach it?